to the cloud. Okay, now I'm recording. Perfect. All right. So let's start with the first section or first exercise. This is section, so exercise number 1. This is from section, this is from section 2.1. This is probably, this is gonna be like your first problem in the test. Yeah, so you have this frequency table, etc. So yeah, so we have the following data. This is a list of numbers of students visiting this professor from the music department, visiting his office each week for 2 semesters. So that's 30 weeks. And so we have the following data, the following number of students. So yeah, well, I mean, I can write down the data. It's like 30 numbers. Well, again, I don't know if you have the review sheet in front of you, but anyway, let me just, I'm gonna write down the data values in very quickly. So the data values are, so we have 15, 23, 17, 13, 3, 9, 7, 6, 8, 11, and then 16, 32, 27, 4, 20, 3, 28, 5, 6, and then 11. And finally, you have 20, the last line, we have like 20, 12, 8, 10, 25, 10, 8, 15, 11, and 9. Okay, so this is your data value. So in A, you have to make a frequency table with 5 classes, right? So, so we need to make a frequency table with 5 classes. So the number of classes, guys, of course, so it depends on the problem, right? Here, we need to make a frequency table with the 5 classes, but again, it depends on the problem. So in the test, it could be like, it could be different than 5, okay? It could be less or more than 5, it depends on the problem, okay? But here it's 5 classes in this problem, and you have to show the classes boundaries. So in this frequency table, you have to show the classes boundaries. Right, the midpoints, frequencies. There's the relative frequencies or relative frequency, and then cumulative frequencies. Anyway, so yeah. Anyway, so the first step, it's always, as a first step, you need to find the width of your classes, frequencies. So as a first step, so we need to find, as always, the first step, whenever you want to make a frequency table, you need to find the width. Okay, so how do we do that? To find the width, you need to find like the smallest so you need to take the difference between the smallest and the largest data values. So like here, the largest data value would be, let me see, I think it's 32, right? 32, yes. That's the largest data value. And the smallest data value, it's 3. So then you subtract. So you take the difference between 32 and 3. So that will be 32 minus 3 over, okay? And then you divide by, you know, the number of classes. So you divide by the number of the classes. Here it's, so 29. So here we need, as I said, we need 5 classes. So we divide by 5. All right, so this would be, you're using your calculator, that's 5.8. Now the width would be the next whole number, okay, or next integer. So next integer, of course, would be, so next whole number, that will be your width. So in this case, it's, I mean, after 5 point, the whole integer or whole number, sorry, whole number, right after 5.8, that will be 6, right? So the width here would be equal to 6. All right. Is there any question, guys, about that? I think I heard someone. Okay, probably not. All right. So that's the width. That's the first step. That's always the first step. Now, after with the width, we need to find the class's limits. Okay, so for the class's limits, this is step number 2. Say this is step number 2. So for the classes limits, guys, well, so classes limits, so it means like we have like an interval. So there's the lower limit and there's the upper limit. Okay, so there's this lower limit and there's the upper limit. All right. So for the first class, guys, so class or first class, so we have 5 classes. Fourth class. Feel free to interrupt me, guys, if you have any question, right? So fifth class. Now, what will be the lower limit of the first class? Sorry, Ferdian, I missed your question in the chat. Isn't there 30? I forgot 30. I'm sorry, let me see again. I don't see the 30. What do you mean? You mean 30 numbers, right? Oh yeah, we have 30. Did I miss a number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 30. There are 30 numbers. I don't think I missed any number.
Yeah, it's all there because you got
it's all there,
right there. It's 2. Yeah, it's 2 3s.
2. Yeah, 2 3s. Yeah, right here, and there's a 3 right here.
Yeah.
Yeah.
Oh my God.
Okay.
I'm sorry, somebody.
Ferdian, does this? I mean, do you see that we have like 30 numbers here? Okay.
Yeah, no, I said it. I was a little confused with the 29, but I see what you did there. It's okay.
29. Okay. All right. I'm sorry. I mean, if you have the review sheets on, then it's I guess it's not a big deal. Yeah. So the first class, guys, the lower limit, that's always the lowest value, or your lowest data value. So the lowest data value is 3, right? That's like the smallest number, and so that will be the lower limit of the first class. So the lower limit of the first, so this lower limit of the first class is just the 3. That's the lowest number. Now, for the next class, the second class, the lower limit, all you have to do, guys, is to add the width. So 3 plus 6, right? This again, the 6 is the width. So 3 plus 6, that will be 9. Plus, again, plus 6, that will be the lower limit of the third class. So that will be 15. For the fourth class, 15 plus 6, that will be 21. Okay, it's always plus 6. And 21 plus 6, that will be 27. All right, that's for the lower limit. Now for the upper limit, all you have to do, guys, you take the lower limit of the second class, which is 9, and you subtract 1. Okay, so it's 9 minus 1, that will be 8. So the upper limit of the first class is 8. So it's always, you always subtract 1 from the lower limit of the second class, right? This is 9 is the lower limit of the second class. So you subtract 1, that will be 8. That's why I got this upper limit equal to 8. And now next, For the upper limit of the next classes, all you have to do is just to add the width. So here is like +6, +6. So 8 plus 6 would be 14. Plus 6, that would be 20. Plus 6, that would be 26. Plus 6, that would be 32. All right. So this is the classes limits. Any question, guys, for the classes limits? Okay, perfect. Now I can make my frequency table. Now we are ready to make, this is like my step number 3. So now once we have the class limits, then you are good to go. And we can make our frequency table. So we're gonna have like classes boundaries. And then what else? I forgot. Let me see. So we said, yeah, sure. So make a frequency table with 5 classes showing class boundaries, class midpoints. Right, and then next we have frequency. Next we have yeah, relative frequency. And then finally we have the cumulative frequency. All right. Now for the classes boundary, guys. So what we do is we have 5 classes, of course, but what we do. So let me just. So 1, 2, 3, 4, and then 5. So the lower boundary, guys, it's just you subtract 0.5, 0.5 from the lower limit. So it's a lower limit minus 0.5. And for the upper boundary, it's the upper limit plus 0.5. All right, so for so my first class, the class limits are the lower limit is 3. So then for the lower boundary, we have to subtract 0.5. So that will be 2.5. Now for the upper boundary, we add 0.5 to 8. That will be 8.5. Right. Next, second class, the lower boundary is 9. We subtract 0.5, so that will be 8.5. What I mean by 0.5, of course, it's 0.5, right? 14 plus 0.5, that will be 14.5, etc. Right? So this is 14.5, and then 20.5, and then 21.5. Sorry, subtract. So that will be 20. This is 20.5, and then 26 plus 0.5. So that's 26.5, 26.5, and then finally 32.5. All right. So that's for the classes boundaries. Now for the midpoints is just the point between in the middle of the lower boundary and the upper boundary. So like for the first class, so the midpoint, I'll just remind you of the formula. So the midpoint is gonna be lower boundary plus the upper boundary, or lower limit plus the upper limit. So it's lower plus upper boundary or limit. I'm gonna get the same same answer over 2. That's the average. All right, so for example, first class, lower limit of the first class is 3. Upper limit, it's we said it's 9, I think. Where is it? Sorry.
8.
8, sorry. Thank you. Thank you. So over 2. So there'll be 11 over 2, and there'll be 5.5. Okay. I mean, it's the same thing. You can also take the class's boundaries. I mean, you can take, again, for the first class, you can just take, it's the same if you use the class's boundaries. So that's like 2.5 plus 8.5. All right, over 2. And that's again, so it's going to be same thing. It's 11 over 2, which is 5.5. Okay, so it doesn't matter if you use boundaries or the limits, I mean, the class's boundaries or the class's limits, you're going to get the same answer. So anyway, so yeah, so the midpoint of the first class is 5.5. Now for the next classes, guys, you don't have to compute anything, just to add plus 6, like plus 6 here. That will be 11.5 for the next class, plus 6, 17.5, plus 6, that will be 23.5, and plus another 6, that will be 29.5. Okay, so it's plus 6, etc. Right? So once you compute the midpoint of the first class, then all you have to do is just to add the width. Right? Okay. Okay, I guess there are no questions. Now for the frequency, of course, the frequency, you have to find or to count the number of the values in your class limits, right? So for the first class, the class's limits are 3 and 8, right? So you count how many values are between 3 and 8. So between 3 and 8, let's see. For example, sorry, this is 32. Yeah, so between 3 and 8. 3 and 8 both, I said 3 and 8, right? So 3 and 8 both are included. So it's, we have 3, what else? 4, between 3 and 8. I don't want to miss anything. So this is 7, 6, 8, 6, 5. And there's this 8 right here. Right, this is supposed to be 32. I'm sorry about that. This is 32, I think. Yes. All right. Do we have 10? Let me see. 1, 2, 3. I'm missing something else, I think. Or yeah, there's another 8 right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, I think we have 10 values. So 10 values between 3 and 8. And again, the 3 and 8 guys are included. So you have to include the 3 and you have to include the 8. All right, so we have 10 values. So the frequency of the first, I think it's first class is 10. Is there any question about the frequency of the first class, guys? You see how I got this 10? Just count how many values are between 3 and 8. 3 and 8 are the classes limits of the first class. 3 and 8 both are included. Okay. Now for the next class, we have 9 and 14. Well, I mean, I have the answers, but I'm gonna just probably do this again with you just to make sure that you understand how I got the answer. So for between, sorry, second class, we said between 9 and, where is it? Yeah, 14. Okay, so 9 and 14. So we have 9, oops. Let's use a different color. Okay, 9, there's 9 and 14. Between 9 and 14, there's this 13. There's this 12, there's this 11. And do we have, I think, we are supposed to have like 8?
No, 9.
Did I miss anything else?
The 10 right there. There's another 10. It's another 10 next to the 8 that you have.
Oh, yeah. Thank you. I'm sorry. Yeah, there are actually 9. That's not 8. Sorry, I missed the 10 actually. in my notes, I think I missed the 10. Thank you, appreciate it. Yeah, so there are, yeah, as you said, there are so then 9 values. between 9 and 14, right? So, oops. So yeah, there are 9 values here. And then I think, so I guess you understand how it works. So then for the third class, it's the number of the values between 15 and 20. I think the answer is 4. I have 4.
I have
And my
6.
note 6. Did I miss again
Yeah, I
some
have
numbers?
6.
Okay, I think I missed some numbers there. All right, that's not my 9. Okay, so it's 6. And let me see. So then for the fourth class, that's weird. For the fourth class, it's between 21 and 26. I got, so let me check. 21, between 21 and 26, 23, 21 and 26, 26 and 21, both are included. And there's a 25.
Yep.
And that's it.
20.
Right?
Oh, no, you're right. You're right.
21
Yeah, I have
and
2.
26, right? 2, right? I have
Yeah,
2.
I have 2.
Okay.
Yeah.
I got, okay. That's good news. I got a right answer. 2, and then finally for the last one. So the thing, guys, is that the total, the in your column, in this frequency column, the total should be the size of the sample or the number of the data values, right? We have 30 in total, right?
Yeah.
30 data values, or 30 numbers. Here, as you can see, 10 plus 9, that's 19, plus 6, that's 25, and then plus 2, that'll be 27. So then the frequency of the last class should be 3, because the total, the sum of all these numbers should be equal to 30. That's because we have 30 data values. All right. Now for relative frequency. So relative frequency, guys, just to remind you the formula for the relative frequency. Relative frequency, it's equal to the frequency over the size of the sample. So relative frequency. So relative frequency, that's the frequency over the size of the sample. Okay. So for example, size of the sample, again, just the number. This is the number of the data values. How many numbers do we have, right? This is like in this example, of course, we have 30 numbers. So the size of the sample is it's 30. So like frequency of the first class is like 10 over 30, right? And that will be, just use a calculator. So 10 over 30, that will be 0. So that's 1/3. So that's 0.33. All right. For the second class, it's 9 over 30, which is actually, let me check my notes. Right. Need to check my notes.
0.30.
Yes. So that's, as you said, yeah, absolutely. That's equal to 0.30, 0.3. And then, so we have 6 over 30. That's actually 0.2. This is actually 1/5. Then we have 2 over 30. All right, so this is actually 0.06, right?
7.
7,
Because
yeah.
you would round up, so it's
Yeah,
equal
yeah,
1.
yes,
Okay.
6 or 7. Yeah, absolutely, you're right. And then 3 over 30, which is 1/10, 1 over 10, and 1/10, of course, that's just 0.1, right? Okay, perfect. Cumulative frequency. Yes? Is there any question there? Juliana, are you asking a question? I'm sorry.
Yeah, Y7.
Y7, you're talking about this?
Yes.
Um, I mean, you just divide the 2 by 30, right? If you divide 2 by 30, the 2, that's because the frequency of the class is 2, and 30, that's because the total number of the data values is 30. That's the size of the sample. We have 30 numbers. That's why we divide by 30. So
Yeah, I understand this, but I calculate 2 by 30 is six.
no,
Um,
actually, no, actually, no, 2 over 30 is 0.066. So this is actually 0.066, etc. So the thing is, you see here, because this is the third number here, or the third digit is larger than the 5. I mean, you can round your answer, so then that will be 0.07. But I mean, actually in the test, both answers for me are correct. So you're gonna get full credit if you say it's 0.07 or 0.06. Okay, both answers for me are correct. Okay.
The only reason I made it a point was because, you know, when you say the relative frequency, when you add them all up, they're supposed to equal
Yeah,
1.
you're right. You're right.
It'll make
Yeah.
it it'll make it seem like
Yes.
the answer is wrong. So that's
No,
why.
no,
I
no,
said
no,
something.
no. Yeah, I know. But because I know exactly. Yeah, that's exactly. Yeah, that's true. But anyway, I mean, both cases, you're gonna get full credits. Okay, don't worry about that. It's not really about. I mean, if you have like the right steps, I see you applied the right formula, then you're gonna get full credits. I mean, it's not really about how we compute the number. It's really how we get the number. Anyway. All right, guys. And then for the cumulative frequency, guys. So for the first class, of course, the cumulative frequency is just the same as the frequency of the class, right? It's just the same thing. Now, for the second class, the cumulative frequency would be the cumulative frequency of the class, which is 9, plus the frequencies of the previous classes, right? So the previous class is the first class, and the frequency of the first class is 10. So that's 9 plus 10. So the cumulative frequency of the second class would be 19. For the third class, the cumulative frequency, well, first you start with the frequency of the third class, which is 6, plus the frequencies of the previous classes. So the second class, we had 9, and in the first class, we had 10. So the total is actually, so this is 25. For the fourth class, the frequency is 2, plus the frequencies of the previous classes. Actually, the frequencies of the previous classes is actually 25, right? So the answer would be 27. And finally, the cumulative frequency of the last class is 3 plus frequencies of the previous classes. That's 27. So that's 3 plus 27, and the answer would be 30. Okay. Is there any question about this? Let me check the chat. Okay, no, there's no question. Okay, perfect. All right, guys. So we got this is our frequency table. Where's my, I need to find my, okay, here's my review sheet. Yeah, so now in B, we have to draw the relative frequency histogram. So just be careful, guys. I mean, the histogram depends on so I mean, usually the histogram would display the frequency, but here we are asking for relative frequency histogram. So here the histogram is going to display not the frequency, but the relative frequency. Yeah, so here in B, so relative frequency. But anyway, so for the histogram, guys, the the horizontal axis is going to be always given by the class's boundaries. So this is always classes boundaries. So classes boundaries, of course, on this number line, this is supposed to be a number line. You're going to put the 0 first, and then you're going to put your classes boundaries. So like here, classes boundaries, you know, you have 2.5, 8.5, etc. So I'm going to put my 2.5, that's the boundary, the lower boundary of the first class. And then we have, I think, 8.5, 14.5, if I'm not mistaken. And then 20.5, 26.5, and then 32.5. Okay, so this is, again, this is just the class's boundaries. I got these numbers from here. I got these numbers from, you know, from the class's boundaries. 2.5, 8.5, 14.5, 20.5, 26.5, and 32.5. All right, now on the vertical axis, as I said, this depends on the problem. So here we have to display the relative frequency. So on the vertical axis, I'm gonna put here, I'm gonna put the relative frequency, not the frequency, but the relative frequency. Okay. So let's see the values of the relative frequency. So relative frequency, we have 0.33, 0.3, 0.2, 0.1, and 0.07 or 0.06. Yeah, so let's put these values on this vertical axis. So here, let's say you have 0.07. We have, I think we had 0.1. There is 0.2. Yeah, and 3, and then 33. So 0.2, 0.3, and then 0.33. All right, so first class, guys, relative frequency of the first class we said is 0.33. So so this interval, this interval represents the first class, right? Because this is the class's boundaries of the first class. So it's between 2.5 and 8.5, right? Boundaries of the first class. Now, we said the relative frequency is 0.33. So here is my relative frequency. So it's 0.33. So I'm gonna draw this rectangle right here over the first interval, or the first class, the 2.5, 8.5. So yeah. Again, the height of this rectangle is 0.33 because this 0.33, that's the relative frequency of the first class. Now for the second class, so second class, so let me change the color. Yeah, second class, we said the relative frequency is 0.3, right? So so this interval here, this represents the second class, and it's 0.3. So we're gonna, the height of this rectangle.
I have a question, Professor.
Yes. Yeah, please.
I thought it was the between the cumulative frequency and the other one. I thought it was gonna be on the Y side, 10, 19, 25, 27, and 30.
You're talking about the values on the horizontal
Yeah.
axis right here?
No, the other one.
Oh, right here on the vertical axis.
Yes, because I was seeing the on the previous class, on that side was supposed to go the cumulative frequency.
No, that's not true. So for the histogram, so the histogram displays, of course, it depends on the problem. So either displays.
I'm sorry, the frequency, not the sorry,
yeah, that's why.
Frequency.
That's why. Yeah. Okay, that's that was my point. That's what I was saying. I was saying, so, I mean, yeah, usually the histogram will display the frequency, but here in this problem, you see it says draw a relative frequency histogram. So sometimes actually the histogram will display this relative frequency, not the frequency, because
Okay.
it depends on the problem. So if the problem's, if the problem just say, well, draw the histogram, so then use
It
the
will tell
frequency.
you which
Yeah,
one you're gonna use.
yeah.
Okay, okay, okay,
And,
okay.
and, and
Got
Okay.
it.
if,
I
yeah,
have one question. So
yes.
if we accidentally don't pay attention, because I did the same thing, I did the frequency. If we don't pay attention and we do the frequency, will we get some type of points or the whole graph?
Yeah,
Because
yeah,
it
no,
ends
you're
up
gonna
being
get,
the same graph.
you're gonna get, no, it's not the same graph, but you're gonna get partial credit.
Okay.
If, yeah, but if it doesn't say like, doesn't say anything, just say like draw the histogram, then it means the frequency histogram. But here it's really specified. It says like relative frequency histogram. So if it's specified, sorry, the kind of frequency you need to display, then yeah. So like in this case, that would be the relative frequency. But in general, if it doesn't say anything, it would be just the frequency.
Okay, okay, I got it.
Mhm,
Thank you.
mhm. Yeah, sure. Yeah, so however, for the ogive always display the cumulative frequency. Yeah. So for the third class, we have 0.2. So that would be this rectangle right here. Right, this is, as you can see, the height of this rectangle is 0.2. The fourth class, it's 0.07. So for the fourth class, 0.07, and then last class is 0.1. So right here, so it's 0.1 for the last class. I just want to remark, guys, I mean, because I saw in the homework, I think some of you want to draw the histogram. I don't know, for some reason, they put like a space between like the rectangles. Okay, but actually in the histogram, there is no space between the intervals. Okay, so it's like the rectangles, there's no space between the rectangles. Okay. So I mean, I saw some of you actually when they draw the histogram, they had like some space between the rectangles, like this. Okay, but there actually there's no space. Okay. So that's not correct. So yeah, there's no space between my rectangles, as you can see. All right, next. Unless you have a question, guys. So next, where are we? Yes, the ogive. The ogive. So the ogive. The goal of the ogive is to display the cumulative frequency. So that will be the C, I guess. It's not the C, but anyway. So this is for the ogive. Okay, so the ogive actually displays the cumulative frequency. Right. So just to remind you that the ogive, guys. So you have your classes boundaries as usual. I mean, classes boundaries is always your horizontal axis. So again, you're gonna have like the 0, 2.5, again 8.5, 14.5, 20.5, 26.5, and then the 32.5. All right, so now for the vertical axis, you're gonna have, as I said, the cumulative frequency. And then you always, so when you draw your ogive, you always start from the starting point, it's not 0. I saw, I mean, some of you actually in the homework, for some reason, they started from 0. So the starting point, it's not 0. It's the first lower boundary. So we start from the first lower boundary is 2.5. So you start your graph or your ogive from the 2.5, from the first lower boundary. Okay. Yeah, before graphing the ogive, I need to put the cumulative frequencies. So my cumulative frequency, we have 10, 19, 25, 27, and then 30. So let me just put on this. So 10, 19, I think 25, and then 27, and then we have 30. So the first, the cumulative frequency of the first class is 10. So what I'm gonna do, I'm gonna use the next point, which is the 8.5, to plot the cumulative frequency of the first class. Next, second class, cumulative frequency is 19. So here is my next point. Cumulative frequency of the third class. So I'm going to use the next point, and it's actually 25. Cumulative frequency of the next class. So I'm going to use this point here. And cumulative frequency of the fourth class is actually 27. And of course, cumulative frequency of the last class, it's just 30. Okay, so then your ogive would be this graph right here. Just connect these points, okay? You can just forget about these lines. All right, and this is your ogive. Let me see if there's any question, guys. Let me see check the chat. All right, no questions. Okay, perfect. So that's the ogive. All right, so we can move to the next problem then, or next section. So this is, I think this covers section 2.1, the frequency table and histograms, etc. There's one more thing, guys, actually, sometimes you need to describe, the shape of the histogram. Okay, don't forget you have this some descriptions of your histogram, like the skewed left, skewed right, or regular histogram, etc. So yeah, you can probably take a look to the shapes of the histograms. So I don't know if it's, well I know, of course, but it could be in the could be in the test, okay, where you have to describe the shape of the histogram. All right, so yeah, let's move to the next section. So this is this is exercise number 2, review sheet. So exercise number 2 actually covers the section 3.1. So it's about the measures of variation and central tendency. So we have the mean, median, etc. So let's start with A. First, we need to find the mean, the median, the mode of the data from Professor Hill's class. So for the mean, guys, so just to remind you the mean, well, here we have 30 numbers, but I promise in the test, you will have probably just 5 numbers. I think you're gonna have just 5 numbers. But here in this review sheet, because you have time, to practice. So that's why I guess you have like 30 numbers, but in the test, you're gonna just have like 4 or 5 numbers, no more than 5, okay? Otherwise, because it's gonna be too much. Yeah, so like here, the mean, that will be the sum of all the data values. So you have to add, the 15 to the 23, plus the 17, plus the 13, plus the 3, plus etc. So then plus the last number would be like, 9, right? Again, this is my data values, and we have 30 data values. So this is the sum of our data values, right? Over, and then we have to divide by the size of the sample or the number of data values. So how many data values we have? Well, here, of course, there are 30 numbers or 30 data values. So we have to divide by 30, right? Anyway, so in this case, the mean, I think the sum of the data values, I think is going to be 392. So the 15 plus, the 15 plus the 23 plus 17 plus 13, etc. That'll be 392 over the number of data values. As I said, we have the 30 numbers. And so the answer, if I'm not mistaken, is 13.06. Right? So that's for the mean. Let me check if, is there any question in the, oh, Shakwana, sorry, I missed your question. You're saying that will be skewed left. Yes. Yeah, the histogram of the previous question, I'm sorry, I missed your, I didn't check the chat. Yes, that will be skewed left because you have the classes with the largest frequencies on the left side. Yeah, that will be skewed left, yes. Let me just say yes. Right, so that's for the mean. Because I have to keep an eye on the review sheet and at the same time on the chat, so it's like sometimes I just miss some questions on the chat. But anyway, so then you have to find the median, right? So this is for the mean, and then for the median. So the median, guys. So how do we find the median? So there are two steps. First, you have to order. So as step number one, so we have to order your data values from the smallest to the largest. From the smallest to the largest. Okay, so like here, in this case, of course, the smallest data value is 3, right? And then how many 3s actually? We have 2 3s, right? So it's 3, 2 3s, and there is a 4, just 1 4, thank you. 1 4, and then I think just 1 5, 2 6s, yeah, 2 6, 1 6, and then another 6, etc. Right? So you have again, you have 30 numbers, and the last number, of course, that will be the largest number. That will be 32. Okay. So you have to order your data values. I mean, I hope you see what I mean here by ordering the data values, right? And then, so that's the first step. And then as a step number 2, you have to find the middle position. So the median would be the number, it's supposed to be the number in the middle position, right? So the median, so we have to find the middle position. Okay, so we have 30 numbers, right? So we have to find the middle position of your data set. So actually we do have a formula for middle position. If you have in this case, we have 30 numbers, right? I mean, to find the middle, I mean, the idea is just to say, well, the middle position is actually 30. We have 30 numbers. So the middle position is actually 30. This is the formula for the middle position. So it's 30 plus 1. Don't forget to add the 1 plus 1 over 2. So plus 1 here is really important. Okay, it can make a difference. So here, the middle position would be 31 over 2. So that's 15.5. Okay. So as you can see, guys, here, the middle position, it's not a whole number, it's actually decimal. And this is just because we have because we have an even number of data values, right? So for example, so what I'm saying is, if you have like 4 numbers, we have 4 numbers, right? This is we have even number of data values, right? Where would be the middle position? Well, the middle position between, between the second and the third number, right? It's not the 2, it's not the 3, it's between the 2 and 3, right? That's why I got a decimal here. It's like here, the middle position would be like the 2.5. 2.5, it's between the 2 and the 3. So it's like between the second and the third number, right? So yeah, don't forget the +1 when you want to find the, well, anyway, in the test, of course, you're gonna get just like 5 numbers. So it's kind of clear where's the middle position. That will be the third number. But I mean, in general, middle position would be like the total number of data values +1 over 2. So when I say 15.5, I mean, so then the middle position is between the 15th and the 16th data values. Let me just erase this thing here. So, I mean, what we are saying is that, so the middle position is between, it's 15.5, so that's between 15th and 16th data values. Right, so what we do is we count our data values. This is like the first data value. This is like my second data value. This is like my third, etc. And then the 15th, I think, the 15th data value. Let me see my notes. I think it's gonna be 11. I think so. Yeah, I think it's in my notes. It's written 11, so I think it's 11, and the 16th is I think it's also 11. All right. So then, guys, the median. So that will be the 15th data value plus the 16th data value over 2. That will be the average. Okay, so that will be the 11 plus the 11 over 2. That'll be 22 over 2, and that'll be 11. The answer is 11. Again, the 11, this is because this 11 is because this is in the 15th position, and this is in the 16th position. Right? Makes sense? I hope so. All right, so now the mode. So next, the mode, right? So what's the mode, guys? The mode is just the number which occurs most frequently. So so you count, for example, here, which number is occurring the most? Let's see. For example, I think 8 is occurring 3 times, right? 8 is occurring 3 times. Same for 11, right? Is it 3 times? Yeah, 3 times. Actually, 11, 8, both of them, they're occurring 3 times. So I think so. The answer here for the mode, actually, we have 2 answers. It's 8 and 11. Okay, because both are occurring 3 times. Okay. I think that's yeah, both are occurring 3 times, if I'm not, yes, yeah, that's what I have in my notes. Okay. Of course, well, here, because both are occurring 3 times, but for example, if 8 is occurring 4 times and 11 just 3, then of course the answer would be 8. Okay. Any question, guys, about the mode? Let me check the chat. Okay, no questions about the mode. Perfect. Okay, next then, what's next? yeah, the weighted average. So we have the median, mode, that's done. So then the next in B, exercise number 2B. So we have to find this weighted average. So this is about the weighted. So the weighted average. All right, guys. So we have this class, biology, 340. So we have this weights. So research, it's worth 25%. 3 exams, each exam worth 15%, and there's a final worth 30%, right? So we have this student, Gary. He got, Gary, he got how much points on the project? 75. So 75 on the project, right? And the weight of the project is actually worth 25%. Okay. He got 85 on the first exam. And the weight of the first exam is 15. He got, that's exam for first exam, sorry. Second exam, he got 95. I think he's a very good student. So exam number 2, and exam number 2 is also 15%. Exam number 3, he got 90 points. Uh, 90 points, and it's also 15%. That's the weight, right? That's the weight of the third exam. And finally, the last exam, the final, he got 88 on the final. And the final is worth 30%. All right, guys. So yeah, so as you can see here, this is like the weights. This is the weights of the the test. Let's just the weights by W. That's your weights, and your data values, or your your X, or your data values. So your data value or data values are just the scores on the tests, right? So so let me just first remind you what's the formula for the weighted average. So the weighted average is given by, so this is the formula for the weighted average. So this is equal to the sum of the X times W over the sum of the W's. So the X, guys, that's just the data value. The X, it's just the data value, or the score in the exam. And the W, that's the weight. Okay. So, so like in this example, the sum of this X times W, like in the first, in the project. So in the project, so as you can see in the project, Gary, he got 75, right? That'll be your X, and the corresponding weight, it's actually 25%. So X times W, that will be 75 times the 25%. Okay, so it's 75, that's your X, that's the score in the exam or in the project, times the weight, that's 25%. Right? Plus, right? Because this capital sigma here, guys, it means the summation, right? This is a symbol for, this is a summation. Okay, so yeah, this is for the project, right? Now, for the first exam, he got 85. That's your data value times the weight, which is 15%, etc. Plus, and the second exam, he got 95 times the weight, corresponding weight of the second exam, again, 15%. Third exam, he got 90, and we have the same weight. And then final, he got 88, and the weight, corresponding weight, the weight of the final, it's 30%. Okay. Now, guys, just to explain this percentage, when I say 25%, it means 0.25, or 15%, it means 0.15. Or in other words, so when I say 25%, this is like 25 over 100. So the percent, again, the percent means division by 100. You divide by 100, 25 over 100. That's the 25%. And 25%, 25 over 100, that will be 0.25. Okay, so the percent is just division by 100. All right, so yeah, so let's compute this thing. Well, it's so it's like 75 times 0.25, that's the 25%, plus the 85 times 0.15, plus 95 times 0.15, plus 90 times 0.15, plus 88 times 0.30. Okay, and the answer, where is my answer? Yes, right here. So we have the answer here, guys, would be 85.65. Okay, so again, this is the sum of the X times W. Okay, so now next, guys, so we got our numerator, right? Now we have to compute the denominator. The denominator is the sum of the weights. Okay, the denominator, that's the sum of the weights. So sum of the weights, so let's do this. Sum of the weights. So the weight of the first exam, or the first, I mean, the project is 25%. So we have like 25%. That's the weight of the project. Now the weight of the first exam is 15%. The weight of the second exam is 15 again percent. Same for the third exam, and finally the final is 30%. So yeah, as I said, 25% is just 0.25 plus 0.15 plus 0.15 plus 0.15 plus 0.30. Okay, so now the 0.25 plus 0.15 plus 0.15, etc., the answer would be 1. It's equal to 1. Okay, so then find answer. So the weighted average that will be, again, the sum of the X times W over the sum of the weights. So that will be this 85.65 divided by 1. And so it's just equal to 85.65. Okay, that's Gary's weighted average in this biology class. All right, guys. Any question about this? weighted average. Let me see the chat. Okay, no questions. All right, okay, cool. Now, so I guess we can move to the, so this is section 3.1. We can move to the next exercise number 3. It covers the section 3.2. So exercise number 3. So we have this range, variance, and the standard deviation, coefficient of variation, Chebyshev's theorem. So in A, we have to find the range, sample variance, and the sample standard deviation of above data from Professor Hill's class, right? So for the range, guys, range is kind of simple. There'll be the largest data value minus the smallest one. So like in our example, the largest value again, we said it's actually 32, right? That's the largest value. And the smallest value is 3. So the range is 29. Okay. Next, we have to find the sample variance. Okay, so yeah, I guess I need to remind you the formula for the sample variance. So the variance would be, so the variance, that's the S square. Okay, and that's supposed to be the sum of the X square minus the sum of the X's squared over N, and then the whole thing over N minus 1. Okay. All right. Yeah. So first, let's start with. We're gonna need first this sum of the X square. Okay. So this sum of the X square. So what do we mean by this summation? I mean, the sum of X squared. So you take the square of the first X. The first data value, like the first data value would be 15. So 15 squared plus next data value is 23. So that will be 23 squared. Next data value is 17. That will be 17 squared, etc. Okay. So, but as I said, guys, for sure in the test, you're gonna have to compute this sample variance or sample standard deviation, but you're gonna have probably just 5 numbers. Okay. So anyway, so here we have like 30 numbers. You take the square and then there's sum, and I think I have the answer to this. If I'm not mistaken, I mean, if my computations are correct. So this is supposed to be equal to 6,896. Okay. So that's what I mean by this sum of the X square. All right. Now, next thing we need to compute is this sum of the X's. Okay. There's the sum of the X's, and then you need to take the square. So the sum of the X's, of course, it's just the sum of the data values. So the sum of the X's is like 15 plus 23 plus 17 plus, etc., etc. And I think the answer to this again is going to be 392. Okay. Now, what else? Yeah, we need the N. N, and this is again just the size of the sample. And because we have 30 numbers, so N is 30. That's the number of data values. You have 30 numbers, so N is 30. All right, so I guess we are good to compute this S square. So this S square would be like, first, we have the sum of the X squared. So this is this number here, 6,896. minus, and then here it's the square of the sum of the x's. So this is the sum of the x's, which is 392, but then it's squared. Okay, there's a square over n, that's 30. And then the whole thing divided by 30 minus 1, right? That'll be 29. Again, n is 30, so n minus 1, that'll be 29. So what do I mean, guys, by 392 squared? That's 392 times 392. Okay, so this, when I say 392, sorry. When I say 392 squared, this is like 392, times 392. Okay. And then you divide by 30. So actually, if I'm not, so if I check my notes, so the answer for this should be, so this is s squared, should be 6,896 minus, so this should be 5,122 over, and then divide by 29. Okay, and the final answer, this should be equal to 61.16. Okay, so again, guys, how I got this, how I got this 5,122. So what I did is I first, I multiplied 392 by 392, and this is actually equal to, let me see my notes. Did I compute this thing? Sorry about that. Yeah, so this is, we said 392 times 392. This is actually, this is 153,664. And then I had to divide by 30, right? So then 153,664 divided by 30, that will be this 5,122. Okay, that's how I got this 5,122. Any question, guys, about this? How I got this s square? I mean, this is really important. For sure, you're gonna, in the test, you're gonna have to compute this s square. And as I said, it would be just for 5 numbers, not like it's not as crazy as this. Okay. Let me see the chat. Okay, I don't see any questions in the chat. All right, cool. So that's for the s square, right? We got this is the variance. And then the standard deviation s. So s, that will be the square root of s squared. So that will be the square root of the 61.16. Okay, and square root of 61.16, it's actually 7. So make sure, guys, you need to know how to compute the square root with your calculator. Okay, usually the square root would be like a second function in your calculator. Okay, if you have like a kind of advanced calculator, so the square root would be just a second function. Okay, so you need to press like second function, and then the button where you have like this is square root, right, and then you can enter your number. Yeah, so I was saying this is the square root of 61. That will be 7.82. So that's my variance. Okay. What else? Yeah, that's all for A, right? Sample variance, the sample standard deviation of the above data. Okay, we got that. Now for B. So the B, it's about this Chebyshev's theorem.
Professor, somebody said they have a question in the chat.
Okay, thank you. I'm sorry. Okay. Yes, Juliana. Yes, Juliana. Yes, please. What's your question? It gave you 61.17. Both are, again, that's depends on your calculator. So I guess your calculator is actually rounded the answer, but yeah, both answers are correct. 61.16 or 61.17, both are correct. Okay.
Okay, thank you.
Mm-hmm. All right. Sorry, I have to come back to my review sheet. Yes, here. All right, so now there's this random sample of receipts for individuals eating at Applebee's restaurant. So this random sample had a sample mean of, so X bar, so this is, sorry, this is B. So our X bar, it's actually $10.38. Okay, and the sample standard deviation S, our S is $2.17. All right, and then you need to compute the coefficient of variation of this data, and then use the Chebyshev theorem, to find the smallest interval, etc. So first, guys, for just to remind you the coefficient of variation, remind you the formula. So coefficient of variation, it's actually denoted by CV. Again, CV just stands for coefficient of variation. So this is, just to remind you of the formula, it's S over X bar times 100, and then you have like a percent. Okay, so that's the formula. It's S over X bar times 100%. So, like in our example, the coefficient of variation would be, so S is the 217, right? It's given, it's just 2.17 over X bar. X bar, it's the $10.38, right? Times 100, and then there's percent. So first thing, guys, using your calculator, you can divide the 2.17. If you divide your 2.17 by the 10.38, right? 2.17 divided by this 10. Let me find the answer in my notes. So this is actually 0.29. So if you round your answer, this would be actually 0.21. Okay, times, this is actually multiplication. This is supposed to be, sorry about that, but this is multiplication, right? This dot means multiplication. So we have to multiply by 100. So 0.21 times 100, that will be 21. And then there's a percent, so 21%. Okay. All right. So that's for the coefficient of variation. Now, next, yeah, the Chebyshev's theorem. Yeah, we need to find the smallest interval centered on the mean, in which we can expect at least 75% of the meal receipts to fall, right? So for the Chebyshev's theorem, guys, so you need to make sure that you have the right interval. So just to remind you here for this Chebyshev's interval. So if you have 75%, then the interval you need to use is actually X bar minus 2S, X bar plus 2S. That will be your Chebyshev's theorem interval. Sorry. If you have like 88.9% in the problem, you're looking for an interval with at least 88.9% the values falling in this interval, then the interval would be X bar minus 3S, X bar plus 3S. If you need, or if you want a 93% interval, so that'll be X bar minus 4S, X bar plus 4S. All right. So in this exercise, yes. Let me see again. Okay. Okay. There are no questions. All right. Yeah. So in this exercise, guys, it says. Okay. I guess this is Candy. All right. Yeah. So.
I have some trouble with my tablet. I don't know why it's coming out.
That's fine. That's fine. No problem. So yeah, guys. So let me just find again my review sheet. So here, so we said this. So it says we need to use the Chebyshev's theorem to find the smallest interval centered on the mean in which we can expect at least 75% of the mean receipts to fall. Right. So in our exercise, it says 75%. So in the exercise, it says, so we need a 75%, right? So because it's a 75%, so we need to use this interval. This is the answer, okay? But of course, you need to plug your X bar and S in the intervals. So yeah, so our Chebyshev's interval would be X bar minus 2S, X bar plus 2S. And of course, X bar here, X bar, it's $10.38. That's X bar minus 2 times S. It's 2 times, this is multiplication. S is $2.17. So it's $2.17. Right, and then we have again the upper limit. It's X bar again plus 2 times S. So times S, which is the $2.17. So yeah, so then this would be equal to, so this would be my interval, of course. So 2 times $2.17, that will be minus $4.34. And here plus 4.34. So then the answer here would be $6.04. And here that will be $14.72. Okay, so what we are saying, guys, is that we expect at least 75% of the receipt to fall in this interval. Okay, so there are 75%, at least 75% of the receipts actually are between $6.04 and $14.72. All right, again, guys, the formula for the interval depends on the percentage. So if you see 75%, that will be this interval. If you see 88.9, percent, that'll be the second interval. If you see 93%, that will be the third interval. Okay, so the interval depends on the percentage you see in the problem. All right. Are there any questions? Let's see in the chat. Okay, there are no questions in the chat. All right. Okay, cool. Let's move to the next problem then. What's the next problem? Okay, yeah. So that's section 4.1. This is the scatter diagram. I think we had a lot of exercises about this scatter diagram and the correlation coefficient. So this is exercise number 4. Number 4. So yeah, this is so exercise number 4 covers the section 4.1, the scatter diagram and the correlation coefficient, right? Anyway, so yeah, so as usual, so we have two variables. There's the x and there's the variable y. So the x is the variable x supposed to represent the length of the northern pike. So this is the length of the northern pike in inches. And then the y is supposed to be the weight in pounds. Anyway, this is actually related to the homework number 3, right? Yeah, so first, so you have to, I guess probably this would answer some of your questions, Juliana, right? Because I think you told me you had some questions about the homework. Well, anyway, I hope I'm gonna answer some of your questions from this exercise. And please let me know, interrupt me if you have any question, right? So for A, so you have to graph the scatter diagram. Okay. So of course you're gonna have two axes. This is the x-axis, and here we're gonna have the y-axis. So in the x-axis, well, here, as you can see in this problem, we have like, there are like 5 columns. Okay, so that's actually probably that will be the same number of values in the test. So yeah, so we have x, first value of x is 20. So let's just put, well, of course, this is 0 right here. So let's put 20 somewhere right here, for example. And then we need, for example, next value of x is 24. So we're gonna need 24, I guess. And then we're gonna need 36. So this is 36. This is, let's say, and then you have 41. So this is 41, and this is 46. Okay. Anyway, so for y, we have 2. That is 4. We need 4. It says this is 6. This is 8. This is 12, 14, 16, 18, and this is 20. Okay. Anyway, so let's plot the first point. First point, the x is 20, the y is 2. So the first point, x is 20. Here's my x is 20, y is 2. So my first point would be probably this one here, right here. Okay, that's my first point. Next point is x is 24, y is 4. So x is 24, y is 4. So it'll be probably right here. Next point, it's like 36. x is 36, y is 12. Okay, next point, it's 41, x is 41, y is 15. So this is 41, and you need to go up to 15, which is, you know, between 14 and 16, that will be 15. So here's my point. And finally, last point, x is 46, and the corresponding y is 20. So we're gonna go up to 20 right here. So that will be my last point. I don't know if Rihanna, did you had a trouble with the scatter diagram in the homework? Anyway, so this is how we graph the scatter diagram. So let's just forget about these lines right here. All right, so okay. Now, that's my scatter diagram. Then it says using only the scatter diagram, would you estimate the correlation coefficient to be positive, close to 0, or negative? And explain your answer. So what you have to do, guys, you have to draw the line you think best fits the data. You know, the line which comes the closest to each point. For example, here, so probably the best line which fits the data would be like something like a line which is like this, for example, here, okay? Again, the line doesn't have to be like the perfect line. It doesn't have to be the best line. It just you know, just to get some idea about how the increasing or the decreasing of your points or your y values. Okay. So would you estimate the correlation coefficient to be positive, close to 0, or negative in this case? So what do we mean by positive correlation coefficient? So positive means that, you know, your line would be like going up, and if you have a line which is going down, then your correlation coefficient is going to be negative, right? So in this case, as you can see, you have like increasing, I mean, a line which is going up. So our line is going up. All right, so then the correlation coefficient is going to be positive. Okay, positive correlation coefficient. Okay. Let me see if there's any question in the chat. Okay, no questions. Okay. Now next, yeah, here, as you can see, guys, again, this is because it's a review, right? So you have time, you know, you're supposed to have time to do this review, this review sheet. But I mean, in the B and C, you have to compute like the sum of the x's, the x bar, the y bar, the sum of the x's, sum of the y's, etc. But in the test, of course, because you don't really have time, you know, to compute all these things, so they're gonna be given in the problem. Okay. Again, it's just because it's a review sheet, but in the test, all these values are gonna be they're going to be given in the test. Okay, you don't have to compute this sum of the x's or sum of the y's or wherever. Okay, so anyway, so let me just explain again, what do we mean by all these values? So for example, when you say sum of the x's, sorry, so when I say for example, when we say like sum of the x's, it's just the sum of the values of x. Like x, first value of x is 20, second value of x like 24, 36, 41, and 46. That's the sum of the x's. I think it's gonna be 167. That's the sum of the x's. So in the homework number 3, actually, the sum of the x's is actually given, right? Now, sum of the y's, just the sum of the values of y. So it's like 2 plus 4, next value of y is 12, 15, and then 20, which is actually 53, right? We need the sum of the x square. So a sum of the x square, like this is the square of 20, plus the square of 24, plus the square of 36, plus the square of 41, plus the square of 46. And again, when I say 20 square, that's like 20 times 20. Or when I say 24 square, that's like 24 times 24, okay? And I think the answer for this, the answer would be 6,069. Okay. Let me see if there's anything in chat. Yeah, this is actually a good question, Amy. As I said, so section 5, I didn't cover section 5.2. I actually covered sections 5.1. So 5.1, yes, 5.1 is going to be in the test. 5.2, it's not in the test. So what you should expect in the test is one problem from 5.1. So this exercise 5, exercise number 5 in the review sheet is actually, it covers 5.2, not 5.1. So 5.1, it's how we compute like very basic probabilities. I mean, I can do a couple of examples after this exercise. I think I send you the notes. I mean, you can take also a look to the notes, but yes, the section 5.1 is in the exam, yes, not the 5.2. So it's not the exercise, and not the exercise, the exercise number 5 here in the review sheet. Okay. Does this answer your question, Amy? Okay, perfect. I'm gonna try to do my best. I mean, to think about an exercise which would cover the 5.1, not the 5.2. I mean, again, 5.1 is very, I think it's not really hard. It's very, very, very basic probabilities. But yes, I will probably give you like try to give you like an idea about this 5.1 after this exercise. Yeah, so yeah, for the y square, the answer, again, the 5 squared will be like 2 squared plus 4 squared plus 12 squared plus 15 squared, etc., plus 20 squared. So the answer here is 789. And then you're gonna need the sum of the x times y. This is supposed to be like, so it's like first x times the first y, second x times the second y, third x times the third y, etc. Then we have 41 times 15, and then you have 46 times 20. Anyway, so the answer here, I think, is 2103. Okay. Now we can compute our R. So again, just going to remind you the formula for the correlation coefficient, R. So R, this is supposed to be sum of the, supposed to be N times sum of XY minus sum of the X's times the sum of the Y's. And then denominator, we have like N sum of the X square minus the square of the sum of the X's. And same thing for Y, and sum of the Y square minus the sum of the Y's squared. All right, so in this example, N, that's the number of the points. We have 5 columns, so we have 5 points. So N is 5. Sum of the xy, that's the 2103. So that's times 2103 minus, and then this is sum of the x's, that's the 167 times the sum of the y's. Sum of the y's, that's the 53 over square root, again, n, and it's 5. The sum of the x squared, that's this 6,069. So times 6,069. And here, be careful, guys. This is the sum of the x's and then squared. So first you need the sum of the x's. That's what's inside the parentheses. So this is like Pemdas rule, right? A parenthesis and then the exponent. So parentheses, inside the parentheses, I have the sum of the x's. That's the 167. So I have my parentheses, I have 167 inside the parentheses, and then I have this square. Same thing for y, so we have 5 times y squared, that's the 789, minus, again, parentheses, sum of the y's, that's the 53, and then there is a square outside the parentheses. All right, so first, so if you compute this, the 5 times the 2103, that would be 10,515 minus. Now, on the other hand, you have this 167 times 53, that's 8,851 over, and then here some of the, so here we have like, there's this 5 times 6,069, that will be equal to 30,345 minus, and then there's this 167 square. So this is like 167 times 167, 167 times 167, that'll be 27,000. So this is 27,889 times, we do the same thing for y. So this is 5 times 789. 5 times 789, that'll be equal to 3,945 minus, and then this is 53 square. That's like 53 times 53, and that'll be 2,809. Okay. So first, guys, we need to subtract. Okay, so you subtract this thing here in the top. So R would be, so here in the top, the 10,515, etc. Minus the 8,851, that will be 1,664 over. And then we have 2 square roots. Okay, so be careful, guys. First, you need to do the subtractions. So we subtract first. So first, here, this thing here, 30,000, etc., minus the 27,000, that will be 2,456. So this is 2,456, and then there's another subtraction. This one right here, that's actually equal to 1,136, if I'm not mistaken. So this is 1,136. Right now, you need to take the square roots. So this, we have R, there's this 1664. First, you need to do the square root. All right. So again, this is Pemdas rule. You do the parentheses, and then your exponent or the square root. So square root of 2,456. This thing here, this would be equal to 49.56. So this is 49.56 times the other square root. So the square root of, this 1136. So square root of 1136, that will be 30, I think 33.7. Okay. And then now we can multiply. So R, again, it's 1664 over this 49.56 times 33.7, which is, I think, 60 or 1600. I think it's 71 point something. I think it's 71 or something. So this is actually the answer. I mean, if you divide, that will be the 0.99. Guys, so this is the R is 0.99, which is very close. So it's almost perfect. This is almost equal to 1. So then the correlation is very, very strong. So because R is actually very close to 1. So then the correlation is very strong, actually, is very strong. Again, so if your R is close to +1 or close to -1, then the correlation is very strong. If your R is kind of close to 0, then the correlation is very low, okay? Close to 1, close to -1, very strong. Close to 0, it's very low. Any question, guys? Juliana, do you have any question about this problem? Again, I think because you had trouble with the homework. Nope. Okay. All right. Yeah. So as I said, so for the exercise number 5, exercise number 5 covers 5.2. I mean, I was supposed to cover 5.2 last week, but I just we didn't have time, right? So I just covered 5.1. So that's why this exercise, you can just ignore this exercise number 5. Okay, so just ignore 5. And however, exercise number 5, the 5.1 is actually number 5. However, section 5.1 is in the test. Okay, and 5.1, it's just about, I mean, we had basically just one formula in the 5.1. I introduced the notion of probability, and to compute the probability, we said, so the probability of an event A, I think we had a couple of, we had a lot of exercises last Wednesday, last week. But just to remind you, guys, the formula, so probability of the event A, so this is the probability of the P of A. I mean, what I mean by P of A is the probability of the event A. The event A, okay? So yeah, so probability, again, it's a number, supposed to be a number between 0 and 1. And the way we compute the probability is most of the time it would be the number. So this is the number or the frequency. It's the frequency of the event occurrence. The event occurrence. Frequency of the event occurrence divided by, of course, by the size of the sample. Okay. So that's how we compute the probability of an event A in general. The frequency of the event over the size of the sample. So let me give you an example, guys. I mean, as I said, we did plenty of examples last Wednesday last week, but yeah, I'm gonna just remind you with an with an example. So something, let's say, similar to the exercise number, kind of, which looks like the exercise number 5. So let's say we have exercise. So let's say we have a survey of 400 students. Okay, so we have a survey of 400 students, and let's say we have, among the 400, we have let's say 120 students measuring in computer science. Okay, let's say we have so 120 students measuring in computer science, 80 students measuring in, let's say, chemistry or biology. Let's say biology. 20 students measuring in chemistry. What else? So computer science, biology, chemistry, let's say business and administration. Let's say we have 50 students measuring in business and administration. And so how many? So we are supposed to have 400, right? So we have, now we have like, this is 200, 270, and let's say 130 students measuring in, let's say, in English. Okay. So, I mean, as you can see, the total of the students, we have a survey of 400 students, right? So the total number of the students, so it's 400. So 120 plus 80, that would be 200, plus 20, that would be 220, plus 50, that would be 270, and 270 plus 130, that would be 400. Anyway, so for example, okay, Juliana, I'm sorry, I missed your message. Yeah, so for example, guys, I want to compute the probability that a student, so for example, I'm going to compute the probability that a student, so A, probability that a student is measuring in let's say in biology. Okay. So how do we compute this thing? So as I said, the formula is supposed to be the following. So as a frequency of the event, so how many, so when I say the frequency, it means how many, how many students do we have, you know, measuring in, let's say, so here we are talking about students measuring in biology, right? So this is student measuring in biology, right? So frequency of this event. So how many students are measuring in biology? Well, as you can see, there are 80 students measuring in biology. So that's like the frequency of the event. How many times you have students measuring in biology? Well, we have 80 students measuring in biology. So that's 80. So that's the frequency. So 80 over the size of the sample. So how many students in total we have? That's the size of the sample. That's like the size of your survey, right? You have, in your survey, we have like 400 students, right? So in total, we have 400 students. That's the size of my sample. So it's just 80 over 400, right? And 80 over 400, of course, that would be equal to 0. I mean, if you divide 80 by 400, that would be 0.2, which is, of course, 20%. Right, 0.2 is like 0.20, so that's 20%. Okay, that's the probability of that a student is measuring biology. The frequency of the event over the size of the sample. Now, let's say you want to compute the probability that the student is not measuring in biology. That a student is not measuring in biology. Okay. So then the probability of this event, let's call this event the event B. So again, the event B is that a student is not measuring in biology. Okay, not measuring in biology. Okay, so there are different ways actually to compute this thing. First, you can, so again, the formula is the frequency of the event over the size of the sample. So the frequency of the event is the number of the students not measuring in biology, all right? So of course, so what we can do is we can try to compute the number of the students not measuring in biology, right? I mean, we have a total of 400 students, right? And how many are measuring in biology? It's 80, right? So then the number of students not measuring in biology would be like 400 minus 80, right? I mean, everyone else is not measuring in biology, except that, of course, except there's 80 students, right? So, so actually we have 320 students not measuring in biology, right? This is like, or you can just say, well, we have 120 in computer science plus the 20 in chemistry, that's 140, plus the 50, you know, that's 190, plus the 130 in English, you know, that would be the 320, right? So, I mean, there are different ways actually to compute this, the numbers of students not measuring in biology, right? So anyway, so that the answer, anyway, so the number of students not measuring in biology, the frequency of this event is just 320. And again, divide by the size of the sample, which is the 400. Okay, and that will be equal to, I think it's a 0.8, which is 20%. Sorry, 80%, which is, of course, 80%. Okay. But just one remark, guys. I'm going to finish with this remark, unless you have a question about this, guys. So that's basically what we did in this section 5.1, right? Just computing, you know, probability using frequency of the event. But just one remark before finishing this. You see the sum of the students measuring in biology plus, I mean, the probability that the student measuring in biology plus the probability that the student is not measuring in biology, the sum is 20% plus 80%, that's 100%. And 100%, of course, it's equal to 1, right? 80%, that's 100%. That's 1, okay? Now, as I said, so the 20%, this is supposed to be the probability that a student is measuring in biology, right? Now, the 80%, that's the probability that the student is not measuring in biology. So the event B is actually, and that's what we discussed Wednesday and last week, the event B, that will be the complement of the event A. Okay, A is a student measuring in biology, B is student not measuring in biology. So that would be the complement. The non-occurrence of A, that would be the B, right? So the B, this event B, this is, it's called the complement of A. Complement of A. And again, this means this is the event which corresponds to the non-occurrence of A. Okay, so A is measuring in biology, B is, or complement of A would be non-occurrence of A, so not measuring in biology. And so the probability of an event A plus the probability of the complement of the event A, this is always 100%. Okay, and actually complement of A, we denoted this complement of A with AC. Okay, so what I'm saying is that probability of an event A plus probability of the complement of A, this is always equal to 100%, which is 1. All right, guys, probably this would cover the 5.1. So do you have any other question, guys? I think I covered everything in the again in the review sheet except the 5.2. It's not in the test. Yeah, is there any question, guys, about the review sheet, or any question in general, or about the homework? Well, otherwise, I'm gonna stop.
Yes, I have a question.
Yes, please. Yeah.
So you said that we can do our own notes. So why we don't use our notebook, like an open notebook?
No. That's not what I said. So what I said is that we can prepare your formula sheet, but it's supposed to be just one, just one sheet of paper. So you're not allowed to use your notebook, just one sheet of paper. Of course, I don't really care how small you're gonna write. That's up to you, but it's supposed to be just one sheet of paper.
So it's literally one piece of paper, like if we write
Yes.
big or anything like that.
Yeah.
Can we do front and back?
Yeah, sure. You can do.
Okay.
Yeah.
I was about to create a whole formula sheet, and I'm happy she asked us.
But again, you're not supposed to use your notebook. That's not allowed. Yeah.
Okay, no problem.
Any other question, guys?
Professor, when you can you go to the tab? So I need to take a picture because I came late.
Oh,
so can
sorry.
take a picture, please? Thank you.
To the top, like.
All the way to the, in the beginning, because I didn't cap the beginning.
Of this exercise.
No.
Where?
The section 201, I think.
Oh.
The first one, because I came by 6:05, I think.
Oh, okay.
My
Sure.
computer.
Sure.
Thank you.
This is exercise number 2. So probably it's the previous page. Yeah. Okay. Right here, I guess. Yeah. So I guess I'm gonna stop recording at this point. Yeah. Stop recording. Oops.